All right, this is the other version that I think we ask is sometimes we'll ask for just the velocity as an angle magnitude vector, right? And here's a different specification where I'm giving you 32 meters of horizontal distance. And then there's also, I might tell you the elevation here, right? But this is, let's just go with this. Now, remember, it's the same problem, right? So we have these components. We know that the 27.2 cos 75 gives us, what does it give us? Hold on. I've got them on my calculator here. That gives us 7.0399 meters per second. That's x direction, right? And then this is 26.273, and that's meters per second in the y direction. So that's our original velocity. So now let's piece these together. What do we know? We know the things we always know. That's 0. That's negative 9.81. The 32 meters of horizontal distance, that must be this, right? Relentlessly 3 sig figs. Okay. And then I think we can also say our final vertical velocity is 7.0399, right? I don't think we know anything about this. We don't know this. We don't know this. But I think this side's now solvable, right? I can find the time, bring the time across, and then I'll have 3 things. This will be solvable, right? So let's do that. Let's just solve for everything. So let's see. Okay. If S is ut, then t is, what is it? S over u, right? So t is 32 meters divided by 7.0399. Okay. For me, that's, by the way, 32 divided by alpha a. Okay. And I get 4.5455. Dyslexics beware. 4.5455 seconds. Okay, that's how long it takes to do that because, well, there it is, yeah. Okay, so let's see. That's just this divided by this. Did I do that right? I think I did. Okay, and then that'll go right across. So we're going to go 4.5455. I may store that in t. There we go. That's my time. Okay, so now I'm set. I can find the displacement. Even though I don't have to, I'm going to find it. Okay, so just for kicks, S is ut. And I'm doing that because sometimes I don't ask you for the angle magnitude vector. I ask you for these vectors here, the x and the y position, the x and the y velocity. Okay, so let's just plug this thing in. 26.273 times 4.5455 plus 1/2 negative 9.81 times 5. Whoops, that was going to happen eventually. 4.5455. And don't forget to square that. Okay, so here we go. I'm going 0.5 times, no, I'm not. 26.273 times, for me I'm just typing alpha t, and that all of that value gets in there, right? Okay, plus 0.5 times negative 9.81 times 4.5455, which I can do by going alpha t, squaring that. And I get that the height of this thing is a mere 18.1 meters. Now we didn't have to do that. I'm just doing that to show off here. Really, do we need this guy here? So let's find that. V is u plus at. So it's 26.273 plus negative 9.81 times 4.5455. Okay, so 26.273 plus negative 9.81 times times 4.5455. All right, here we go. This is my stomach. Okay, here we go. Sounds, all right, so negative 18.318. Okay, and that's meters per second. So that's my final velocity, right? Okay, now if you recall, this thing, we're doing it at 32 meters. It only goes 37.7 meters, so it's almost hitting the ground, right? It's almost going down as fast as it was going up, right? It's getting there, right? In another less than a second, it'll be hitting the ground. Okay, so let's see. Oh, we got to draw a picture of this guy. Okay, so it's over and down. Much more down than over, though, right? We're looking at this guy here. Okay, so since it says draw the velocity, we look at the velocity. The final velocity is what it is, right? And so let's draw a picture of this. Let's go over. There's our x component. Here's our y, right? That's the vector right there. Make sure that these things have arrows, okay? If you don't put an arrow on there and you don't label which angle you're finding, I reject bare triangles, okay? It must have arrows on it. You must say which angle you're finding, right? So angle magnitude, let's see. That angle there is the inverse tan of opposite over adjacent. So this side is 18.318. This side is 7.0399. So let's go 18.318 over 7.0399. Let's try that. Let's give that a spin. Let's see what it takes, where it takes us. What is that, 18.318 divided by 7.0399. Okay. I'm getting 68.977. Of course, now if I have to round this to 3 sig figs, if I round it to there, it has to go up. So it becomes 69.0. That's the hardest part of the whole problem, is rounding that, right? 69.0 degrees. Okay, and then the magnitude of this, okay, is going to be the square root of, whoops, it's supposed to be a square root sign. It's kind of lame. Okay, so it's going to be 7.0399 squared plus 18.318 squared. Okay, 7.0399 squared plus 18.31. Notice I'm ignoring the minus signs for the purpose of finding those angles and the magnitudes. And that's because TI calculators don't always behave real well when you put negatives in there and square them. Okay, 19.62. So I'll say 19.6 meters per second. Right, so that is this 19.6, right? 69 degrees. I think we're good. I think we're good. We've done so much work. So much work.